All right, section 1.1, we're looking at linear equations. And before we dive into how to solve those, I want to just take apart that word linear equations. So we start with an algebraic expression, which consists of some terms separated by a basic operation like addition, subtraction, multiplication, division. So here's some examples of some algebraic expressions. Now, if I take two algebraic expressions, say I take this guy, and I put an equal sign between them, well, now that's an equation. So that equal sign with two algebraic expressions, one on each side, that makes it an equation. So even though, like in this example, I have on the right-hand side, I just have an 11, well, that is an algebraic expression. An algebraic expression is one or more terms combined through basic operations such as addition and subtraction, multiplication, division. Well, this is one term on the right and two terms on the left. So an equation is just an equal sign with algebraic expressions on both sides. Now, what makes an equation linear? Well, that means if I try to graph that equation, I would get a line, which happens when I have no exponent. So my highest exponent is a 1. So if that doesn't actually show, because when I have a 1 there, it's just understood, and I don't have to write that 1. So an equation with no exponents and a variable is a linear equation. So that's what we're solving here. And every linear equation has a variable part and a constant part, and you can manipulate it to be in this form. And if once it's in that form, then I just want to get that x by itself. So I'm going to do it generally first before we do the examples. I have to get rid of the b. So if I have a plus b, then I would just subtract b from both sides to get all the constants on the on the right. And then to get x by itself completely, I would divide both sides by a. And I get x equals b over a. All right, let's look at some concrete examples of that. So in 1.1, I'm going to split this into two parts. It's actually 1.1.1. We're not going to do 1.1.2 in this class. So 1.1.1 has two parts. I'm going to use part A first to talk about this part of your homework, 1 through 29, every other odd. So that exercises 1 through 36. We're actually just going to do 1 through 29. So here's 3 examples from that section, and your homework are similar to these problems. So you're doing 1 through 29 every other odd. So I'm going to do 3 problems that aren't assigned as your classwork. So this is part of your classwork, your lesson 1 classwork. I'm sorry, not lesson 1. Not lesson 1. Yeah, lesson 1. That's right. Lesson 1 classwork. So I want to make sure however you're submitting your classwork, be it if you're doing all the notes and on copying this down, then you're filling in those 3. And if you're using your own notebook paper, please make sure you're including these 3 problems. All right, so let's look at some classwork problems. So the first one, number 3. So remember we said we want to, actually, you know what? Before we do that, let's look at these steps down here. We're going to follow these steps. So these are a little general. So simplify the algebraic expression on both sides of the equation. Gather all the variables on the left and all the constants on the right. And then get that variable all by itself. So number 3 is already in that simplified form. So I just want to gather all the variables on the left and the constants on the right. I have a constant here on the left. I want to get rid of that. So to move that over to the right, I add it. I do the opposite operation. It's a -3, so that means I'm going to add 3. And whatever I do on the left, I have to do it on the right because I want to keep it equal. So that gives me, on the left, these cancel, and I'm left with just n. And on the right, I get 12 plus 3, which is 15. And that one I'm already done with. So I like to check it just to make sure I didn't make any arithmetic errors. So I just plug that n back into there. Sometimes it's simple enough that you can actually just plug the 15 like that and say -3 plus 15. That does give me 12. Check. All right. For my notes purposes, though, I'm going to write that out. So sometimes if I'm just working privately, I will just check it kind of in my head like that. but since I'm teaching, I'm going to write out what I was thinking, which is this, and then that is true. So that gives me my check. Okay, so that's my thinking. All right, let's move on to number 10. A little more complicated because now I have, no, it's really not. It's about the same complicated. So again, I want to get my constants on the right, so I'll subtract 5, and whatever I do on the left, I do on the right to keep it equal. And that gives me a 4p equals, the 5's cancel. The 9 minus 5 gives me a 4. So I get p, and then, oops, I got to show my work. So in order to show my, wouldn't have to necessarily do this, by the way. The orange and the red, sometimes I do that part in my head, but I'm showing you because I'm teaching. But then my 4, I'll divide both sides by 4, and I get p equals 1. All right, so I'm going to take that p equals 1 and just check that. And if I plug that in, I get 4 times 1 plus 5 equals 9. And I want to check if that's true. 4 plus 5 equals 9. So check. Okay, so that's 3 and 10. And then 24 gets a little more complicated. So 24, we're going to throw in a lot of some parentheses and also a couple four terms instead of 3. So a little more complicated here. So I want to remember PEMDAS. Please excuse my dear Aunt Sally. Meaning to simplify that equation, that was the step 1. That's where this comes in a little more important. So we simplify that algebra expression on both sides. So to get rid of that, so the first step of simplifying would be that P, the parentheses, or grouping symbols. So I need to get rid of the parentheses, and I do that by taking what's in front of the parentheses and distributing. So my 4, I want to multiply it by the y and multiply it by the 6, which gives me a 4y plus 24. That negative 8, nothing happens to it. I just carry it down. And then I have a 2y, and I have a minus 4 times y plus 2 in parentheses. So this gets a little tricky in that sometimes in our pre-lesson, you saw that negative in front of the parentheses where we distributed the negative. That one's pretty commonly done correctly. But a lot of times I see an error here where we have the negative and a number, and it's so tempting to just take that 4 and distribute the 4, but we have to keep that negative still. So it's negative 4 times y and negative 4 plus 2. And that's going to give me negative 4y and a minus 8. So make sure you keep that it's a negative 4, not just 4. All right. Now, on my next step, I actually see that I have a negative 8 on both sides of this. I'm going to use my orange marker. I'm tempted to just not necessarily do the simplifying and the gathering, but the negative 8, since that's there on both sides, and I kind of would like to keep my numbers small rather than combining that with a 24 and keeping it unnecessarily. So remember, an equation is kind of like a scale. Let's see. How do you draw a scale? I don't know how to draw a scale. I'm thinking of like one of those like lawyer scales. Let's see. How do we draw a scale? Like I said, so say we have a little scale here. We have the same number of beads on each side. Well, if I take away one bead from each side, if I take away exactly the same thing from each side, then it's still going to be equal. So that negative 8, I'm just going to take that away from both sides. And that way I have a simpler equation and I don't have to deal with subtracting that. Okay, so I just took away that negative 8 from both sides. Now I want to gather all my constants on the right. So I have this plus 24. So I'm going to subtract that. And whatever I do to the left side, I got to do to the right. So that leaves me with a 4y. I've subtracted 24 and my negative 8s have canceled. And on the right, I have 2y minus 4y. I didn't do anything to those. Minus 24. And then I can combine like terms. I see I can combine these two. So the 4y, oops, sorry, that should be a blue one. 4y is already in simplest terms, but that 2y minus 4y, I can combine those because those are like terms. So I'm going to rewrite that as a negative 2y minus 24. And again, I want to gather all my variables on the left. So this is step 2 now. So adding the 2y to both sides. I get 6y on the left, and I get, these will cancel, and I get a negative 24 on the right. Now to get the variable isolated, so this is step 3, I want to divide both sides by 6. So I get y equals negative 4. So that's my final answer, but I'd like to check it just to make sure I didn't make any mistakes. So get that y and negative 4 and substitute in for y there. And that gives me 4. And then for y plus 6, that's negative 4 plus 6 minus 8 equals 2 times y, which is negative 4, or 2 times negative 4, minus 4 times y, which is negative 4 plus 2. All right, and then checking this, I get 4, negative 4 plus 6 gives me positive 2 minus 8. And on the right, I have 2 times negative 4 is a negative 8. And then I have minus 4 times negative 4 plus 2 gives me a negative 2. So that's minus 8 plus 8. So on the right, I have a 0, and on the left, I have a 0, and those are equal. So that's how I can check that. All right, so that is this page of your notes/classwork. So remember to turn this in as part of your lesson 1 classwork.